Hello, today we will be deriving the quadratic formula. And the method we will use today is also known as completing the square. So we all know that when solving quadratic equations, there's like three main ways to do it. So first is factoring, right? Like you first find the root, factor it as like this, right? So this is one method, right? Where R1, R2 are the roots, and then you can just read off the values here to find the roots of this equation. The other is using the quadratic formula if the roots are not easy to find. And the third method is called completing the square, and we'll go more into that when deriving the quadratic formula. So if you're wondering where the quadratic formula even came from, well, the method we use is actually just completing the square, and we'll look more into what that really is. Okay, so right now we have this, and because a does not equal 0, well, if we imagine if a equals 0, then this is just bx plus c. This is not a quadratic expression, right? This is just a linear expression. So because a does not equal 0, this means that we can divide both sides by a. So after dividing both sides by a, we have x squared plus b over a x plus c over a. And 0 divided by a is 0, so here's a 0 right here. Now, completing the square. To complete the square, we're going to write this expression in this form. So we're going to write it as x plus h squared plus k equals 0. And then h and k are variables to be determined in terms of a, b, and c. The reason why this is more helpful than this. So you know that when there's an exponent, right, you want to use the square root in order to isolate the x right here. But the reason why we can't do this is because we have a bx right here, right? And if we try to rearrange this and then take the square root, well, we have x equals the square root of something x, right? And we can't really, it's not really easy to solve. However, the completing the square method right here, because h and k are like constants, right? We can rearrange this equation as x plus h squared equals negative k. And the thing here is that now we can take the square root of both sides, because now what we get is x plus h equals because we're solving there's a minus sign here. Because we're solving equations, right, we must not forget about positive negative of a square root right here. But of course, always a good idea to check back, like plug this into your equation and check again. And now you notice that we have isolated our x after we move our h to the other side. So this is why perfect square, completing a square, is another powerful tool in order to solve quadratic equations. Okay, well, what about here, right? How do I complete the square? To complete the square, what we do is that we first add a certain constant to this equation right here, such that this will be a perfect square right here. So like this plus another constant. But because this will actually change the value of our expression right here, we have to subtract that constant again. Actually, we probably don't need to subtract right here. We can actually just add the constant to both sides right here. What is this constant exactly? Well, this constant we will be adding is so we will be adding b squared over 4a squared to both sides of the equation. So we know that whatever we do to one side of the equation, we do the same, and we do the same to the other side. This is still equal, right? But the cool thing here is now this right here, you'll notice that this is a perfect square. We can actually factor this as x plus b over 2a squared, right? So if you expand this out, you'll notice that you'll get this. And then we have plus c over a equals b squared over 4a squared. Okay, and this is, we have completed the square right here. And all there is left to do now is to move, isolate our x, take the square root of both sides, and then we are finished after that. So now we will be moving our c over 8 to, so we'll subtract c over 8 on both sides. And we can simplify this right here. So what we do when we subtract fractions, so make sure that the denominators are the same. And in order to do this, we multiply the top and bottom by 4/8, right? So this will become b squared minus 4ac over 4a squared. So it seems like it's getting a little low right here. Maybe I can move to this side. Okay. So now we're going to take the square root of both sides. And what happens is we get x plus b over 2a equals. So we must not forget about the plus minus sign, right? So plus minus b squared over 4ac over, yeah, so when taking square roots of a fraction, one thing you can do is to first take the square root of the numerator and then the denominator. The square root of 4a squared is 2a. Yeah, we can see that 2a, if you do 2a times 2a, you'll get 4a squared. So here it is. And now one last step is that we just have to isolate x. And to do that, we subtract b over 2a from both sides of the equations. So our final result is x equals negative b positive minus b squared minus 4ac over 2a. Yeah, this is also known as the quadratic formula. So now what we are going to do is that we are going to apply completing the square to any equation, quadratic equation. So okay, so let's say we have a equation 2x squared plus 9x plus 5 equals 0. Alright, so we want to solve for x right here. So doing our completing the square method, we first divide both sides of the equation by 2. So this will give us x squared plus 9 over 2x plus 5 over 2. Yes. Okay, now we want to factor, we want to add a constant to both sides. So previously, we knew that this constant would be b squared over 4a squared, right? So now, so in this case, it will be a1 over 16. But we'll check this later. Okay. So now you notice that this should be a perfect square. And this factors as x plus 9 over 4 squared. And plus 5 over 2. Okay. So we'll move 5 over 2 to isolate x. So 81 over 16 minus 5 over 2. And here we can just multiply numerator and denominator by 8 in order to get the same denominator here. and we get x plus 9 over 4 squared. This will be 41 over 16. Okay, so now we will be taking the square root of both sides of the equation, and we get x plus 9 over 4 equals plus minus square root of 41 over 4. And then as our last step, we will subtract 9 over 4 of both sides of the equation, and we get x equals negative 9 plus minus 41 over 4. This should be our final answer right here. However, of course, in math, if you get a final answer, it's always a good idea to double check this with 2 different methods. So again, recalling what our quadratic formula is, right? We have x equals negative b plus minus b squared. So we have this, right? Of course, there's probably many methods right here to remember this, but here it is. Okay, so now we will just substitute values for a, b, and c. So right here, what does a equals? A equals 2, right? So we have a equals 2, b equals 9, and c equals 5. And what I'm going to do is that we are just going to substitute into this equation for x right here. X equals, so b is 9, so it will be negative 9 plus minus, so there's 9 squared minus 4 times 2 times 5 over 2 times 2. Yep, okay, so if you evaluate this, you get 81 minus 40. This should give you 41, and 2 times 2 is 4. Our answers matches for 2 methods, right? First, this is called completing the square. Then we use the quadratic formula. We get the same answer. So therefore, we can be fairly sure that this is the correct one here. So from all of this, so there are probably many methods to remember the quadratic formula right here. So there's probably like many songs as well. You probably have, or you guys probably just seen this many times and you just like know what it is. But in mathematics, sometimes it's important. I mean, it's important to also know where this formula came from. And this will help you in solving many more problems and to know when this formula will apply. So yeah, in math, it's important to know, like, to know the derivation of the formula as well. Yeah, thank you guys for watching.